Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for grade 10 students working on quadratic relations. It's the first video from a worksheet in which we're looking at word problems, but I'm not providing you with the equation in the question. And it's question number 1 from that worksheet. So here's the question. It says the length of a rectangle is 2 meters less than 3 times the width. The area of the rectangle is 96 meters squared. Find the dimensions of the rectangle. Okay, so first of all, it's a proper word problem, which means we have to use proper word problem format. So we're going to have to start our formal answer by writing let x or let y or whatever our variables are. So we're going to have to introduce our variables, but let's first, before we do anything formal, let's look at what's going on in this question. We have a rectangle. We know that the area of the rectangle is 96 meters squared. So what do we know about area? We know that area is length times width. So this is really kind of what should be going on mentally when you're reading this question. We have a rectangle with a known area, and we know the equation for a rectangle. And again, what's so important about knowing an equation? Well, if we're trying to find something, if we're solving, we need an equation to solve. So the equation that we're probably going to use is the equation for the area of a rectangle. So area equals length times width, that's what we know. Now, what I always suggest is when you're thinking about what your variables need to be, that you always go back and reread the very last sentence. Find the dimensions of the rectangle. So the dimensions of the rectangle are length and width. And that's usually your biggest hint as to what your variables should be. So if we're trying to find the dimensions, then we're going to use dimensions, in this case length and width, as our unknowns. So let's go ahead and start doing that. So we're going to let, now you're certainly welcome to use W for width and L for length. I just prefer X and Y because of my messy writing. So we're going to let X be the width of the rectangle, and I encourage you to write whatever units are appropriate. We're going to let Y be the length of the rectangle. So there's my let statement. So I'm identifying my variables and what units they are. So, and over here, if you want, we can keep a little picture going. So here's X and here's Y. Now, we need to now write two equations. One equation is going to be the relationship between X and Y. How are X and Y related to each other? And then the other equation will be our area equation. So how are X and Y related? So again, read again. The length of a rectangle is 2 meters less than 3 times the width. That's telling me how length and width are related to each other. We know that the length is 2 meters less than 3 times the width. So here's what 3 times the width looks like, and 2 meters less than it is the length. So double check. Does this say 2 meters less than 3 times the width? Looks good to me. So this is the relationship, this is the equation that shows the relationship between our variables. Now I need an equation that I'm either solving within or maximizing. I'm not maximizing here, I'm just finding. So the other piece of information is area. We know that area is length times width. So there's my two equations. Now I know, so again, you don't have to necessarily have this written. Sorry, I know yellow is tough to see. We know that area is 96, and we know that y is actually 3x minus 2. So we're going to do substitutions, and that's when we can start the algebra part of the word problem. So we know that area is 96, x is just x, but y is actually 3x minus 2. Because if you look here, even if I subbed 96 in, I don't know what y is. So it's impossible to solve one equation if I have two unknowns. So what we had to do was, yes, we had to substitute 96 for area, but we also had to substitute y out of the picture so that we create one equation. Here's my equation, and one unknown, which in this case is x. So once we've written this, Now we just basically, and let me write it a little neater. I'm sorry, I'm scribbling. I know word problems are supposed to be a little bit neater than my normal work. So there it is in slightly neater form. I have one equation and one unknown called x. Let's go ahead and solve. So now I don't care that it's a rectangle for a moment, etc. I just have in front of me an equation and I need to solve. So first of all, let's multiply x times 3x and x times -2. So I can see already it's going to be a quadratic. And in order to solve quadratic equations, we need them equal to 0. So I'm going to subtract 96 from both sides. And there I have my quadratic equation. So how do we solve? Well, we could try factoring. Or let's just go ahead and use the quadratic equation. So x equals -b plus or minus the square root of b squared minus 4 times a times c. All of that gets divided by 2 times a. So again, I've said this in other videos, please don't be lazy with your quadratic equation. This square root line here should go over everything that's being square rooted, and this divide by line should be underneath the entire numerator, not just a tiny little line. So go ahead and do this math. 2 plus or minus root something, that's going to be a 6. So let's see what happens. So I get a discriminant of 1156. Oops, sorry. So let's split that into two distinct answers, one of which is x equals 2 plus, what's the square root of that? 34 divided by 6, and one is x equals 2 minus 34 over 6. So just a little side note, the fact that this square root worked out to be an integer means that I could have factored if I'd wanted to, but, you know, we decided against it. No worries. So x equals 6 over here. Here, I get x equals 5, -5.3 approximately. Now, when you finish solving for x, you always have to, you're not done by any stretch. You have to analyze your results and see if both of them are acceptable and where to go next. So what was x? Well, we decided that x was the width of a rectangle. Is it possible to have a negative width? No, we don't measure anything. Measurement is never a negative number, so we're going to declare that this answer is inadmissible. Now, inadmissible is kind of a special word in math. What it means is this is correct algebraically, but it's not admittable as a solution to the present problem. Ugh. Okay, so there's nothing wrong with the answer. It's not cross it off and erase it or whatever, but it's not admittable in this particular question. So therefore, we get a width of 6 meters. So what's the length? Remember, we needed to find the dimensions, and that means width and length. So we're going to use this equation, again, the relationship equation that tells us how to find y if we know what x is. So we know, we know that x is 6, so we can use this equation and find that y is 16. And of course, finally, we would need to write a statement. Therefore, the dimensions of the rectangle are 6 meters by 16 meters. And again, it's very easy to double check, multiply them, and make sure you get 96 again. Okay, so I hope that that was helpful. And remember, when you're doing word problems, to follow proper word format procedure. And try to be as neat as you can, which is easier with a pen and pencil than it is with a tablet. But anyway, there you go. Maybe I'll see you at the next video. Ciao.